Our next topic is oblique or tilted hyperbola, where the center will not be origin and transverse and conjugate axis will not be parallel to x and y axis. So I have shown the hyperbola in the blue color. So we are going to find the equation of this tilted hyperbola. To find this, we'll take a general or the standard equation of hyperbola and we'll try to generalize the concept. So we know the standard equation of this hyperbola is x square by a square minus y square by b square is equal to 1. So let's take any point P on the hyperbola whose coordinate is x comma y. So the distance of point P from the transverse axis is y and distance of point P from the conjugate axis is x. So I can write x as distance of point P from conjugate axis whole square by a square minus y is distance of point P from transverse axis. So with this general thing, we are going to derive the equation for oblique hyperbola. This TA be the transverse axis and let P be any point. Let us take transverse axis equation to be ax plus by plus c is equal to 0 and conjugate axis P lx plus my plus n is equal to 0. Both the lines are perpendicular to each other. Now if you take the general formula, so numerator is for the first term is distance of point P from the conjugate axis, which is this distance. So you have to use the perpendicular distance formula, mod of Lx plus my plus n divided by root over L square plus m square whole square by a square minus distance of point P from the transverse axis, which is ax plus by plus c by root over a square plus b square. Mod will be there. Since we are squaring it, we don't have to write it. B square is equal to 1. So this is the equation of oblique hyperbola. So the most important thing which you should remember is this concept. If you can remember that concept, then it is just the perpendicular distance formula. Hope it is clear to you. So our next topic is auxiliary circle. So the circle described on the transverse axis as diameter is called auxiliary circle, whose equation is x square plus y square is equal to a square. If you take a hyperbola, so a dash is the length of the transverse axis. Having that as a diameter, you can draw one circle. That circle is called auxiliary circle. So the center of the auxiliary circle is 0, 0. If we know the coordinates of the vertex a 0. So the distance between the center and the vertex is a, which is radius here. So a circle with center 0 comma 0 and the radius a is x square plus y square is equal to a square. Our next topic is eccentric angle of a point P. The angle made by the radius vector through Q, the corresponding point of P with the transverse axis, is called eccentric angle of point P. What does it mean is, this is origin. Let's take any point on the auxiliary circle, which is Q. So this Q point is on auxiliary circle. Okay, the angle made by the radius vector is theta. The corresponding point of Q on the hyperbola will be P. So now you have to get the corresponding point of Q on the hyperbola. For that, draw a tangent at Q. Let's take it is intersecting the transverse axis at N, and then draw a line parallel to conjugate axis. It will intersect hyperbola at a particular point. That particular point is P here. Here Q is the corresponding point of P. This theta is called eccentric angle. So one thing you have to be very careful. This theta is not made with respect to the point P. It is made with respect to point Q. That Q is on auxiliary circle. That is what they have mentioned here. Angle QON is theta. It is not PON. And this theta lies between 0 to 2 pi, and theta doesn't belongs to pi by 2 to pi by 2 comma 3 pi by 2. We'll tell you all the reasons. So theta will lie between 0 to 2 pi except odd multiple of pi by 2. Let us try to get the coordinate of P in terms of theta. We know that coordinate of Q in terms of theta, we know radius is A. So since a point Q lies on the circle, it will be A cos theta comma A sin theta, parametric coordinates of a circle. Now secant theta is equal to ON upon OQ, implies ON is OQ secant theta. OQ is nothing but the radius of circle. So ON is A secant theta. So this length is A secant theta. So obviously the coordinate of point N is A secant theta comma 0 as it lies on the x-axis. Since Pn is a line perpendicular to x-axis, the x coordinate of P remains the same. Let's take y coordinate to be y. As point P lies on hyperbola, it should satisfy the equation of the hyperbola. So in place of x, you substitute A secant theta and y as it is. So from this, secant square theta minus 1 is y square by b square. Secant square theta minus 1 is tan square theta. So implies y is equal to b tan theta. So the conclusion here is coordinates of point P in terms of eccentric angle theta, A secant theta, comma B tan theta. So since the point P lies on the hyperbola, These are nothing but the parametric coordinates of hyperbola. So as I told you earlier, theta is not equal to pi by 2 and 3 pi by 2. Most of you have got now that theta doesn't belongs to pi by 2 and 3 pi by 2. Most of you have got the idea why it is not so. It is because tan theta and secant theta are involved, which is not defined for odd multiple of pi by 2. Hope it is clear to you. So let us divide the branches of hyperbola as this branch basically which lies on the first quadrant, that is right upper branch, and one on the fourth quadrant, right lower, and this is left upper and left lower. The reason for dividing like this, so in this case my point P lies on the right upper branch. Similarly, we have to find for what condition or for what value of theta my point P will lie on the different branches. So we know coordinate as A secant theta, comma B tan theta. So let us assume this is X and this is Y. Let's take theta lies between 0 and pi by 2. In the first quadrant, A and B are positive values. So secant theta and tan theta are positive. So in this case, point P lies on right upper branch. Let's take theta lies in the second quadrant, where both secant and tan are negative. In that case, it will lie on left lower branch of hyperbola. Let's take theta lies between pi and 3 pi by 2. You can include pi here or here, it doesn't matter. So it is in third quadrant now, where tan theta is positive and secant theta is negative. So point P will lie on the second quadrant, where it is left upper branch. If theta lies in the fourth quadrant, 3 pi by 2, 2 pi. I'm not including pi because I will include 0. Where secant theta is positive and tan theta is negative. So it will lie on the right lower branch. So depends on the value of theta, you will be able to predict on what branch of hyperbola P lies. Hope it is clear to you. Let us start with a simple question, which is to find the parametric equation of the hyperbola, a standard hyperbola. Parametric equation is same as finding the parametric coordinates. We know that parametric coordinates are A secant theta, comma B tan theta. So here A square is 36 and B square is 25. So it is basically 6 secant theta, comma 5 tan theta. Next question. So find the parametric equation of a shifted one. So first convert, as of now assume capital X to be X minus 5 and capital Y to be Y plus 3, so that it will change to X square by 36 minus Y square by 25 is equal to 1. Now it is the standard equation of hyperbola, but in terms of capital X. So parametric coordinate is A secant theta, comma B tan theta. So A is 6 secant theta and B is 5 tan theta. So capital X is 6 secant theta capital Y is 5 tan theta. So are these parametric coordinates of the given hyperbola? No. Capital X and capital Y are our assumptions, but we need to find the parametric coordinates in terms of small x and small y. Just substitute the values which we assumed earlier. X minus 5 is equal to 6 secant theta. So x is equal to 5 plus 6 secant theta. Similarly, y is 5 plus 3 and y is minus 3 plus 5 tan theta. Hope it is clear to you. Our next question is to find the eccentric angle of the points lie on the hyperbola which are at a certain distance from the center. So this is the point P. A secant theta comma B tan theta. In general, in this case A is 4, so 4 secant theta comma 5 tan theta. So points lie on the hyperbola which are at a distance root 139 from the center. So this is center, say O. Distance between this and this is root 139 units. So we have to find the eccentric angle, which is nothing but theta. So distance formula, OP is equal to root 139, and we know center coordinate is 0, 0. So which is 4 secant theta minus 0 whole square plus 5 tan theta minus 0 whole square is equal to root 139. Square on both the sides and expand it. What will you get is 16 secant square theta plus 25 tan square theta is equal to 139. So I'll convert everything in terms of tan square theta plus 25 tan square theta is equal to 139. So 41 tan square theta is equal to 139 minus 16, which is 123. So tan square theta will be 3. So tan theta is equal to plus or minus root 3. So theta will be 60 degree in the first quadrant plus root 3 and 120 degree second quadrant, and third quadrant 240 degree, and in fourth quadrant 300 degree. There are 4 values of theta which is possible. So basically what they mean here is, geometrically you can take one point P here, one point P here, and one point P on the left lower branch, which will be root 139 distance from the center. Hope it is clear to you.